Are long-running workflows keeping you up at night? Let's mash on that.
Hi, everybody, and welcome to another episode of the Asp.Net Monsters. In today's episode, James is going to talk to us about how to have a good night's sleep. Now, I assume this begins with meditation.
Meditation, you have to have your evening croissant. That's always a good idea. There's a number of things. Yeah.
Is there a difference between an evening croissant and a morning croissant?
Yes, the one at night you have just before bed. The one in the morning you have after you get up.
All right.
So what we're going to talk about is actually, you may have, like we've all worked with at some point, some kind of business function where there's work that needs to be done and we need to keep track of that work. That might even be something that's long running. So there's something called durable functions in Azure. It's actually a pretty robust system for handling these workflows. A really good example of this, actually, something that I kind of racked my brain on is how do they do this, is there's a international pizza chain, and when you order the pizza, there's some interaction that's going on because you're seeing these updates as it progresses through, your order progresses through the kitchen, and even when it departs for delivery. And I was like, wow, this is really cool. There's some continuity from each of these different steps. There's external triggers, there's updates on the clients. How do these kinds of things happen? And this is actually like a really easy way to implement it. So we're going to get into talking about that kind of stuff, but what we're going to do first is we're going to maybe have a little bit a look at how durable functions kind of starts off, how you get information about the progress of a function as it's executing, and those kinds of things. So to get started, we're just going to simply create an application here. I'll just share my screen here so we can see what we're doing. It's asking for a project name. I'm just going to say test the orchestration. Now, this to me feels like workflow code. So if I start using the word workflow, I'm really talking about the orchestration. I'll try to use the right words. Or we'll do like a really bad like dub over later. So Simon and
Please do.
Dave, if you guys could just say the word orchestration right now each, then I will record that in later.
Orchestration.
There we go. Perfect. That was awesome. Okay. Hopefully we don't have to use that. So what I'm going to use is the durable functions orchestration template in the Windows, in the Azure Function application. I'm just going to create that. I've got the local storage emulator. All of the parts you need to do, provided you've got that cloud workflow or that cloud workload, all of the parts you need to do what I'm doing here are included in Visual Studio 2022. So there's no external downloads or anything. This is just comes along for the ride. And right away, I'm going to just show what we get here for free. We'll just do a little bit of Control-M-O. That's right. Okay. To minimize everything. It kicks, there's actually three things in the template. So one is the HTTP start. So it's a poorly named thing, but it works for the illustration purposes. So basically, function one is what we've got. Function one, hello. Function one is the durable function. It's where the orchestration happens, where the workflow plays out. And then function one hello is called by function one. And function one HTTP start is how we enter the code. That's how we get it kicked off and kick off that orchestration so that we can start to move through the code. And there's a couple of things in here. We can see there's a logger that is created for us, and so we can log some information out. This one's really simple. We just say await starter. So now the starter is an durable orchestration client. We say start new async and we give it the name. I really wish that there was a more strongly typed thing, because obviously the risk here is that the strings can get out of sync, but it'll scream loudly at you when it does.
So there is a package that you can add that does code analyzes for this. There's probably two of them out there, because there's one that I wrote and then the functions team took it over and own it now. And then I think there's some work going on too behind the scenes to do like code generation around this stuff to make it a little bit cleaner. I don't know where that is at the moment, but we should have somebody like Anthony on the show at some point, and he can tell us all about it.
Yeah, dive a little bit deeper into that. And so, yeah, that's one of my only complaints. Well, I have other complaints, but that's one of my only complaints I'm going to talk about today. Okay, so now we kick this thing. We started off. I do want to point out there's something interesting. We're going to come back to it, but we actually have the ability to pass in. Like there's multiple overloads for start async. One of them allows us to pass in an instance ID. So if you've got workload that you're starting outside, we're calling that, of course, we're calling HTTP start here. So we're making an HTTP call into this to kick things off. If there is information that you're starting to process external to this workload or this orchestration that we're running in this durable function, we can actually create the instance ID outside of this, and then we will be able to track that externally as well. And we're going to see very quickly why that's important. Now I get a little bit of log information, and then it does this really interesting return thing. It says starter.create check status response with using the request that the incoming request message, as well as the instance ID. And what this does is it generates a JSON object that we can examine as the resulting call to see where we're supposed to go to find out the status of this long-running operation. Because the durable orchestration is about long-running things. It is something that's sitting out there in the cloud, and over some period of time, there's going to be different interactions. There's going to be triggers that come in from files that are getting written to blob storage. There's going to be people pushing buttons in the kitchen saying, I've put cheese on your pizza. So there's going to be these different things that happen, and as the progress updates in that orchestration, you're going to be able to have a client check to see where this orchestration is actually at. Now, there is an activity trigger here. So this is a function that can be executed, and we can use either deterministic or non-deterministic code in this method, meaning I can call out to a web service that returns different results each time. I'm going to generate a result. Now, anytime my orchestration calls one of these say hello methods, or any activity trigger that we invoke, whenever we call one of these asynchronous activities, the orchestration will actually remember the result of that. So that's important, because for replayability and consistency, when our orchestration is run again and again and again and again, as we do all of the things in our workflow that we're designing, then we need to make sure that those things come back the same every time. Let's think about what that might mean. If we're calling out to a weather service, and then the next thing we're going to do is interact with the thermostat in our house. This is a bad example because weather doesn't change very quickly. But if the temperature came back and it was different every time, this example is falling apart on me really quickly, because I do want to change my thermostat every time if the temperature is different. But ideally, like if we're calling out and saying, how much does this thing cost, when we're going to send out an invoice to someone, we want to make sure that that cost that comes back is different, because we might send out an invoice, then we might send out a payment request, there might be a work order. That value has to be the same. So when we compute it, it has to be the same. And these activity functions that we make these calls out to, they are remembered as we navigate through our orchestration. So let's have a look at the default code again. What it does is it calls an async activity, call activity async, and we specify what the result type is. In this particular case, we also specify the name of the function we wish to invoke, and then we've got a parameter. And because we've got the return type, this outputs is just a list of string. So effectively, we've got say hello, we pass in the name. The name, we actually say hello name. We log that out as well, but we say hello name. That's the return value. That's what gets added to our outputs collection, and then the whole thing is returned. Now, we're not seeing too much of the magic here. this is pretty easy to build a list of strings and deal it out and to push that out. But imagine, if you will, that we're actually calling different types of activities based on input or output from previous activity calls. So if the return of this was 10, and I did this one only if it was below 15, I did this one if it was over 15, maybe turning on AC or turning on heating before I continue, perhaps we want our orchestration to remember the results of this call so that our outputs will be consistent from execution to execution. I'm going to run it because some of this starts to make sense. There's a lot to wrap your head around when you're first diving into it, but I want to just kind of give an example of what it looks like when we actually run it. So first of all, this says HTTP start. It says we can get or post. So I'm going to just mark this and pull that in, and I'll bring in a browser over here. And this is the result of that call to the HTTP method. Now, the durable function has started. In fact, I already saw it. It's done. Like, it did its work. Tokyo, Seattle, London. That's fine. But what this method did, this HTTP method did, is it created that check status response. So now I can do things. I can send events into the workflow. I can purge the history of the workflow. Maybe if you've got some sensitive data or data under which you have contracted obligations for how long you store information. We can restart if the orchestration has got stuck, or maybe it has become invalidated based on the status. And of course, we can check the status. So I'm going to click into that status, and then we start to see some really interesting things. And this is kind of where my brain started going, whoa, how much stuff can we do? So there is a runtime status, and that is something that is, it might be waiting for external input. It might be waiting for a timer, et cetera, et cetera. This is set by the durable functions runtime. So we don't do anything with that. But there is a custom status that we can manipulate, and it's any object that'll serialize to JSON. So we can actually maintain a custom status. We can also control, do something more interesting by passing in an input object. And the way to do this when we're using an HTTP trigger is simply to put some object in JSON notation, submit that, and then use parameter binding or deserialize it to an object in the framework of your choice. In this case, I'm using C#. So the output here is simply what we expected. Hello, Tokyo. Hello, Seattle. Hello, London. Now, again, I kind of mentioned that it's not necessarily interesting because at this point, we're not really doing anything in between these calls. But I just want to introduce something else here. We're going to, oops, I restarted. I'm going to stop that. But what we're going to do is we're going to introduce some logging. So we get to take advantage of dependency injection. There's certain things that are available to us. I'm going to pull in an iLogger, and we will start to use that. And I'm going to show you this is where I kind of realized, oh, wait a minute, something interesting is happening multiple times. That's where it became really apparent. So I'm just going to do log information. Actually, I'll log error just so we can see it really easily. So log error, and I'm going to pass in Tokyo, and I will pass in Seattle and London, and I will run this again.
Do you feel like Seattle is kind of hitting above its weight class in that list?
Is what?
Trying to like hit above its weight class in that list.
Here, do you know what?
It's Cloud City.
Brandon, Manitoba.
There we go.
Right. Wow.
Okay.
And you see, James is also demonstrating the problems of not or having comments in your code and in your logs. They get out of sync with the implementation.
Okay, so yes, exactly, right? Because now it says down here, that's exactly, we're just, we're going to let that one slide. But this is
also line 27, but
on line 27 as well. I'm missing. Oh yes. Okay. Perfect.
Anyway,
Yeah.
sorry, I may be dragging us off topic here.
It's all good. It's all good. So what's interesting is I've only invoked the method one time, but if you look at the log activity, what happens is this is replayed every time, right? So Tokyo, Seattle, London. And that's probably not exactly what we want. So instead, there's when we do these kinds of things where we have to be aware of this kind of event sourcing thing, this replayability inside of the orchestration, what we're actually looking for is something a little bit different. And thankfully, we don't have to do much heavy lifting to get logging working properly. What I'm going to do instead is just say logger equals context dot create replay safe logger. Actually, I need to pass in a logger for that. So log, and I'll pass the log into that. And now when I make these method calls, it's going to help us be safe when the methods are replayed. So I'll go back into here. After I've started, I'll hit go. And now instead, that logger's only going to execute on the first time that it's called. And then when it waits for this one and it comes back to this and it's using that replay safe logger, then it knows that it's already made this call out. The reason why this became apparent to me was because I had written an orchestration and I was using logging for exceptions, and there was a part where it kind of entered the exception started firing from one of them and all of them, and because that error got logged on every pass, any of the stuff that failed later on, it looked like all of a sudden there were hundreds of things failing out in prod. And I was like, oh my gosh, what's going on? And so that's when I discovered the replay safe logger. It was very confusing
exciting.
going through those logs. Yeah. Yeah. So no, we're not doing anything too interesting yet, but we do have a direction that we want to go in. And I'm going to pull up something really, it's super handy. I have it really close by. Okay. And we've got the ability to see this happen. Okay. Now we kind of looked at the output from this, the result where we got to see that collection of results or whatever. But if we want to do something that's a little bit more involved and has a little bit more going on with it, then we're going to do this instead. And now we can leverage that result that came back from, we've already got something running. Got to shut that guy down. Press any key to continue. Keep going. Okay. So what I wanted to demonstrate was that idea that I'm going to be able to place this order and then interact with that JSON result that came back. So when we kick off that HTTP start, it comes back with that collection of links. So if I start to use that in the client, then I can start to monitor it and see what's actually happening. And so in this particular case, I'm just waiting for 3 seconds at a time, and then we're advancing the order and sending back a custom status. And we do that so that we're able to update the customer as things go. So this is actually starts to be really interesting. At this point, though, we don't have any human interaction. It's just 3 seconds, 3 seconds, 3 seconds. We're going to look at that on the next episode. So in order to get here, we have to understand some of those basic tenets, but it's pretty easy to get here and interacting with external systems once we understand what's going on at this level.
So on the client side there, are you just polling the status endpoint?
That's exactly right. It's just a 1 second timer in JavaScript, and there is a polling endpoint that's supported. That's that status endpoint that we saw in the JSON links that came back.
That's awesome. I love it.
Yeah, and actually, one of the really cool things that you could do down the road is because we've got functions and because we've got a single, like a SWA, like or a single page application, we can use something like static web apps and bring your own API, use durable functions in the back end, and use this guy in the front. So there's no cores to worry about. You can use authentication and all of those things, and it really comes together really easily.
Excellent.
Awesome. So that's kind of what I wanted to show as an introduction to durable functions, and there we be.
All right. Well, thank you for that, James. And there's going to be a part 2 coming up at some point here. So everybody out there should like, comment, and share. And we'll see everybody on next week's episode. Bye.
Thanks.
Bye.
Bye.